observed any black dwarf in the universe because the cooling time it takes billions of years, and this time is more than the age of the universe. Precisely for this reason, we have not observed any of the black dwarf. Just a factual information, इसमें कुछ खास नहीं है. But now consider if there is a massive star, okay, which is many times the mass of the sun, then during the last stages of this star, it explodes, okay, an explosion occurs in the later time of the star's age, and in that explosion the outer layers they fly away into the space, and only the core is left behind. And because the mass is, okay, the core is having so much mass and the fusion reaction stop, fusion is not occurring, so fusion cannot counter the gravity, okay, the outward pressure, the outward thermal pressure because of the fusion reaction, it is not there to counter the gravity. So the gravity will collapse this star. This star will collapse under the gravity, and gravity is so strong that इलेक्ट्रॉन और एक प्रोटॉन को न्यूक्लियर रेंज के अंदर ले आए. ओके, सपोज इफ this is the region of, this is a few Fermi. Now suppose this is a region 10 to the power minus 15 meters. इस रेंज के अंदर न्यूक्लियर फोर्सेस एक्टिव होती हैं, एंड बाय द पुल ऑफ द ग्रेविटी द इलेक्ट्रॉन एंड प्रोटॉन उनको फोर्स कर दिया जाता है इतने छोटे स्पेस में. जब वो इतने छोटे स्पेस में कन्फाइन कर दिए जाएंगे, देन द न्यूक्लियर फोर्सेस विल बी एक्टिव, और इसी कॉम्बिनेशन को न्यूट्रॉन बोलते हैं. तो द ग्रेविटी, द पुल ऑफ द ग्रेविटी इज सो स्ट्रॉन्ग दैट इट पुल्स द, okay, it keeps an electron and proton together within the nuclear range, and a neutron is formed. So under the pull of the gravity, a neutron star is born. But if the mass of the core is 1 to 3 times the mass of the sun, then neutrons are strong enough, okay, to prevent the further collapse. The neutrons, they are rigid enough to prevent the further collapse, and we have the thing that is left behind, it is purely a neutron star. And if this star is, okay, even massive than this, if we have even more massive stars, then the collapse, it will not stop. The collapse will not stop, and a black hole will be formed. And we do not know what is inside a black hole. There is a singularity inside the black hole. We do not know what physical laws governs the, okay, governs the things inside the black hole. अब हमको नहीं पता कि ब्लैक होल के अंदर कौन से फिजिकल लॉज एग्जिस्ट करते हैं. We do not know anything about them, and the space there is infinitely curved. The gravity is very, very strong near a black hole, and the space is infinitely curved. You must have notice such kind of diagram for the black holes. Okay, the lines, they are merging with each other. So these lines, these are the lines in the fabric of the space time. Okay, and the lines, they are merging, they are getting closer and closer. So it shows that gravity is getting very, very stronger, but at the center, okay, they are intertwined very badly. We do not know what is happening at this point. So this is the singular point. This is only a schematic diagram. Okay, it is showing that space is getting distorted. There is warping in the space time. किसी को कोई प्रॉब्लम यहाँ पे? एक बार, yes, Meenu.
So then you mean the small stars are getting converted into a white star and
white dwarf.
Yes,
yes,
white
because
dwarf.
that, yes,
And heavy stars are converted into
either the
neutrons.
neutron star or the black hole,
Okay.
depending upon the mass.
Okay, the most massive stars getting converted into black hole.
The massive ones, they are getting converted to black hole.
Okay, okay.
And obviously, everything is governed by the beautiful mathematical equations. Okay, and those equations, they are termed as the general theory of relativity. Everything about the universe. Okay, 11th 12th में जब हम physics start करते हैं, then we start with only the Newton's laws, and there are some mathematical equations which describe the everyday events happening in our life. But as we grow old, we start to inspect more about the universe. Okay, and the difficulty level, it increases. But we started with the Newton's laws, and Newton's laws, they have a mathematical form, and the more complex reality like the gravity, it is also having a mathematical form. So in GTR we do the tensor analysis. Okay, we talk about many dimensions. White dwarf people, they never convert into black hole. White dwarfs, they do not convert into the black hole because they do not have enough mass. They do not have that much gravity. Okay, mass and energy, they are something which are distorting the space. Okay, everywhere we have the fabric of the space-time, and the mass, it does something strange to this fabric of space-time. समझ आया हो ना आया हो, लेकिन थोड़ी इंक्यूजिटिवनेस मेरे ख्याल से इसमें बढ़ी होगी. बढ़ी है नहीं बढ़ी है? The universe is not as simple, okay, as we think. And let me tell you one more thing. Starting में जब इस reality से सामना होता है that even the space has a structure, space has some kind of geometry, okay, there is a universal speed, okay, which no particle can cross, like the speed of light. But then we realize that these are the normal things. This is precisely the structure of the universe, and it is only that we realized it much later. Yes, Kritika. In fact, there is something known as Chandrasekhar limit. You must have heard about Chandrasekhar limit, 1.44 times the mass of the sun. 1.44 times the mass of the sun. This is the Chandrasekhar limit. Okay, if the mass is less than this, then the white dwarf will be formed. If the mass is more than this, then we can have the supernova and the neutron star. So this is Chandrasekhar limit, 1.44 times the solar mass. It was his observation that if the mass is less than 1.44 times the mass of the sun, then only the white dwarf will be formed. Okay, and I was here. There is one motivational thinker, Sandeep Maheshwari. Have you heard his name? Okay, some of you might be watching his videos, and okay, he is a knowledgeable person, and okay, the advices that he gives, they are really very good. But and I also watch his videos, but I have found one video in which he is saying that we should not study history. History is a crap subject. Okay, something that sort of. He was saying in one of his videos that history. किसी ने देखी ये video? That history is a crap subject. Okay, so in one of the videos he is saying that हिस्ट्री से मतलब ऐसे सब्जेक्ट को हटा देना चाहिए जिसको पढ़ने से कोई भी हमें लाभ नहीं है. कोई फैक्चुअल इंफॉर्मेशन हिस्ट्री से जो किताबों में लिखी पड़ी है, अकबर के बाबा कौन थे, इससे हमको कोई लेना देना नहीं है, तो इन सब्जेक्ट्स को हटा देना चाहिए. दैट वाज हिज लॉजिक. बट हिस्ट्री क्यों पढ़नी चाहिए, थोड़ा सा मैं इसमें मतलब टाइम लूंगा आपका. You have learned about the artificial intelligence. Okay, how the machine improves? The machine improves by retrieving information from its memory, the data collection, the memory. Okay, it grows with time, it gets larger and larger with time. Okay, the machine, it accumulates data similar to our mind. Okay, and our intelligence, it is derived from the past experiences. Everyone will agree? Our intelligence is derived from our past experiences. And precisely for this reason, we study history. The kind of political situations that we have to handle in the past. Okay, so we learn from those experiences, and that is why you are learning the modern Indian history. And if we completely dissociate the history from you, then you will be nothing. Okay, the scientists, they have built upon what the Einstein has proposed. आइंस्टीन एक बेस बिल्ड करके गए थे और उसके ऊपर आगे साइंटिस्ट ने और बेस बिल्ड किया, एंड दे हैव इवन डिटेक्टेड द ग्रेविटेशनल वेव्स. दिस इज द प्रोसेस ऑफ ग्रोथ. सो अगर हम हिस्ट्री से कंप्लीटली डिसोसिएट कर जाएंगे, देन आइडेंटिटी क्राइसिस भी हो सकता है. ओके, बिल्कुल आइडेंटिटी ही नहीं रहेगी. Political crisis, the situation of women that was in the past time. Okay, so everything is building on the knowledge of the past. We cannot dissociate ourselves from the past. The civilization grows on the past knowledge. We are growing on the theory of the Einstein and what the Stephen Hawking has proposed. So बहुत ज़्यादा टाइम नहीं लूँगा. तो हिस्ट्री को बोरिंग मत समझना, बस एक मैं ये बोलना चाहूँगा. एंड ऐसे जो लोग हैं लाइक संदीप महेश्वरी, दे हैव द ह्यूज फॉलोइंग. ओके, एवरी वर्ड दैट दे अटर, इट रीचेस टू मिलियंस ऑफ पीपल. सो दैट इज अ काइंड ऑफ सुपर पावर, एंड दे हैव टू बी okay a little bit cautious about these things. That is my opinion, and you can differ from my opinion. So there is one more thing. The neutron stars, they are ultra dense objects. They are the densest objects that have been observed in the universe, in the observable universe. And the 1 spoon of neutron star, if you will take 1 spoon of the neutron star on Earth, then it will measure, कोई idea किसी को? Then it will measure about 1 trillion kilogram. 1 spoon of neutron star. It is so much dense. Okay, the density of the neutron star, it is so high that even 1 spoon, the equivalent to a sugar crystal, it will weigh about 1 trillion kgs. Okay, and the stars with even higher masses, if the mass of the core of the star is more than 1 to 3 solar masses, then a black hole will be formed. And for the discovery of the gravitational waves, the 2017 Physics Nobel Prize, it was granted to, please write these names. The name is Rainer Weiss. Okay, the second name is Kip Thorne. And the third name is Barry Barish. Okay, so this Rainer Weiss, I think he is he works at he is the director of the LIGO laboratory. Okay, and the Kip Thorne and Barry Barish. So they are working on this LIGO project, and they were awarded Nobel Prize in the year 2017 for the discovery of the gravitational waves and for validating the general theory of relativity of Albert Einstein. ठीक है. Now, have you heard any of these terms? Antimatter, dark energy. Okay. किसी ने नहीं सुना? Dark matter, dark energy. Now this sounds strange to me. Don't you guys watch the Discovery Channel? Discovery or National Geographic? Okay. It doesn't matter. So we have something known as the dark energy, and this dark energy, it constitutes 68% of the universe. Okay, people. So this dark energy, it constitutes 68% of the universe. And then we have this dark matter. This dark matter, it constitutes 27% of the universe. So this is roughly 95%, and the rest 5% of the universe, it is made up of the normal matter. Okay, the word is normal matter or the visible matter. Okay, only 5% of the universe is made up of normal matter. Normal matter means which is visible to us, our Earth, our Sun, the Milky Way, and rest all the galaxies. Okay, that we can see, it is all the normal matter. And this normal matter, the everyday matter that we see in the universe, it is only 5%. It is only 5%. Okay, and how have they inferred this? From the data that they have collected from the space, the scientists, they have inferred it. They have measured the gravitational effect on the galaxies and the galaxy clusters, and the scientists, they, okay, जो gravitational effect था distant galaxies पर and on the cluster of the galaxies, तो उसको measure करके इन्हें पता चला that there must be some other matter. Okay, there must be more matter in the universe for the extra gravitational effect that they are witnessing. The scientists witnessed the extra gravitational effects on the galaxies and the galaxy clusters, and from that they inferred that we need more matter for this much of gravity. Okay, point clear hai? Because we are encountering, okay, even more gravitational effects than this more gravitational effect. Okay, more matter should be there. So the more matter should be there, but this matter, okay, it is not visible to us. So one thing is that it is not interacting with the electromagnetic radiation. So this new kind of matter, it does not interact with the electromagnetic radiation, means it does not interact with the light. Okay, you can see me because light is interacting with me. Light is falling on my body and it is reflecting from my body, and you are able to see me. Okay, because light is making collision with my body. Okay, so it is interacting with my body and you are able to see me. But light, it does not make any collision with the dark matter, this matter. Okay, and this matter, it also does not emit any kind of radiation. So from the calculation, they have inferred that for the gravity that we are witnessing in this space, there should be more amount of matter in the universe. But the property of this matter is very different from the normal matter. And this matter, dark matter, constitute 27% of the universe. समझ आया? ग्रेविटी के इफेक्ट जो देखने को मिल रहे हैं, ठीक है, उसके लिए हमको ज्यादा मास की रिक्वायरमेंट है, ज्यादा मैटर प्रेजेंट होना चाहिए गैलेक्सी में, ठीक है, और नॉर्मल मैटर सिर्फ 5% है, तो 27% और भी मैटर होना चाहिए. लेकिन ये 27% मैटर ये इंटरैक्ट ही नहीं करता है, ना नॉर्मल मैटर के साथ में, ना इलेक्ट्रोमैग्नेटिक रेडिएशन के साथ में. सो इसीलिए, क्योंकि हम इसकी प्रॉपर्टीज को नहीं जानते हैं, इसको हमने नाम दिया है डार्क मैटर. सो पूरा एस्ट्रोफिजिक्स का जो फील्ड है ये वाइड ओपन है, ओके, for more research on the dark matter and to explain the dark matter, what its properties are. Fine. सबको समझ में आया मैंने क्या बोला? क्योंकि कुछ फालतू ग्रेविटेशनल इफेक्ट्स हमको देखने के लिए मिले थे, उसको एक्सप्लेन करने के लिए है डार्क मैटर. सिंपल सी बात. अब बात करते हैं सर डार्क एनर्जी की. Now let us talk about the dark energy. All of you know that universe is expanding. Okay. From the observational data, we know that the universe is expanding, and it is also expanding at an accelerated pace. Okay. The galaxies, they are moving away from each other at a very faster rate. So, but the scientists, they thought that they were thinking previously that after the Big Bang, because of the intense pressure, thermal pressure from the Big Bang, the universe, it initially expanded. And they reasoned that after some time, because of the pull of the gravity, the universe, it must shrink. But that is not happening. The universe is not shrinking. Instead, the universe is expanding, and it is expanding now at an accelerated rate. This point is the point of the Big Bang. Our universe is expanding now at even a faster rate. So there must be something which is pulling away the galaxies. Okay, the gravity works to pull in everything. Then there has to be something which is pulling apart the galaxies. Okay, सबको बात समझ में आई? And that something जो galaxies को एक दूसरे से दूर कर रही है, there is a dark force. Okay, something is pulling apart the galaxies, and that something is the dark energy. समझ आया? That something is dark energy. कुछ रिएक्शन तो दो. Is it boring? Is it boring?
Sir, what is difference
Yes,
between dark matter and dark energy?
See, the dark matter, it is creating gravity. We have observed some extra gravitational effects. Okay, dark energy is not creating gravity. Dark energy, okay, it is a kind of repulsive force which is pulling apart the galaxies. Dark energy, okay, dark energy is something, we do not know what it is, but dark energy is pulling away the galaxies. And dark matter, the observed gravitational effects, we have the observed gravitational effects. Okay, and we have only 5% of the normal matter. The normal matter cannot explain the observed gravitational effects. Okay, to explain the observed gravitational effects, we need more matter, and that matter is the dark matter. Dark matter is completely different from dark energy. Don't get confused. The observed gravitational effects, they can be explained only by incorporating more amount of matter, and the property of that matter is very different from the normal matter. That is dark matter.
Okay, sir. Got it, sir. Clear, sir.
मतलब समझ में आया ना, या दोबारा रिपीट कर दूंगा हिंदी में भी अगर?
No, sir. Got it this time.
Okay, okay. Yes, Kritika. It is difficult to relate it to reality, but the structure of universe is such that. Nitin, we do not know what this dark matter is. Okay, how can we propose any theory about it? We only know one thing, that there is some kind of matter which is creating extra gravity. Okay, and we don't know anything else about the dark matter. We know only this much, and the field of astrophysics, it is wide open. You can, okay, even you can search for these answers. And now we also have the antimatter. Antimatter is the matter which is composed of antiparticles. Okay, we have particles like the electron. We are talking about the basic particles like the electrons, like the protons. So every particle has an antiparticle. The electron has a proton, electron has a positron. Positron is the antiparticle of electron, and the proton has an antiparticle which is known as antiproton. Okay, so under the standard model of the particle physics, which we will be discussing shortly, okay, from that model every particle has an antiparticle. And it is also, okay, it is also a puzzle that why we do not encounter antiparticle in the nature. During the time of the Big Bang, they should have been, okay, created in equal amounts, but in the observable universe we do not encounter these antiparticles or the antimatter. This is also an unsolved mystery. Okay, this is also an unsolved mystery. Why we do not see the antiparticles? And antimatter is that matter which is composed of antiparticles. मैंने कल बात की थी CERN की, CERN, CERN जो जेनेवा के अंदर लैब है, उसके अंदर साइंटिस्ट ने लैब के अंदर they have created the antiparticles and they have even created the anti-atoms, like they have created anti-hydrogen, and they were able to sustain it for 15 minutes. So antimatter, anti-hydrogen was a reality for about 15 minutes. So what does that mean? That means that physics is not wrong. Okay, even though it may seem that this is not common sense, but this is what the universe in reality is. एंटीमैटर सबको समझ में आया? हर पार्टिकल का एक एंटी पार्टिकल है और एंटीमैटर वो मैटर है जो एंटी पार्टिकल से बना हुआ है. ठीक है, इलेक्ट्रॉन के लिए एक पॉजिट्रॉन होगा और प्रोटॉन के लिए एक एंटी प्रोटॉन होगा. समझ में आता है? ठीक है. नहीं, यूपीएससी में क्वेश्चन इतना आसान आएगा कि आप सही आंसर को तो मार्क कर ही दोगे. ठीक है. So this is a diagram. We have only, this is the visible matter. Okay, this is the visible matter, and the proportion of visible matter is very small, and then rest we have the dark matter, and we do not know about the dark matter. Anything about the dark matter, we do not know it. Thank you, Kritika. So we have discussed this question yesterday, and there is one more thing. There is one more thing. Please write gravitational lensing. Gravitational lensing. Yes, Kapoor. हेडिंग लिख ली, ग्रेविटेशनल लेंसिंग. नॉर्मल लेंसेज किस तरीके से वर्क करते हैं सबको पता होगा. हाउ दी नॉर्मल लेंसेज दे वर्क. सी, इफ वी हैव अ लेंस, this is a converging lens, and when the light passes through a lens, okay, this light converges. So what the lenses are doing? The lenses, they are bending the light. Yes, Disha, we have the concave lens and we have the convex lens. So any lens, what a lens is doing, it is, okay, it is converging the light rays or it is diverging the light rays. Basically a lens is bending the light rays. Now suppose we have massive bodies. There are massive bodies in this space, and you know them very well. There are very, very massive bodies in this space. And now suppose a ray of light was moving near a very heavy object, and because of the pull of the gravity, it will deviate. Just as a lens was bending the ray of light, in a similar way, okay, the masses, they are able to bend the ray of the light because they have distorted the space-time geometry. So the ray of light bends when it passes near the massive objects. Okay, clear? I hope it is clear. And this simple phenomena is gravitational lensing. This is gravitational lensing. Yes, people, the answer is D. Ruxana, a lens, basically what a lens does, a lens bends the ray of light. Okay, in a similar fashion, when a ray of light, it passes near a very massive object like a black hole, then it bends. Because the space is distorted near a heavier mass, so when a light ray passes near the heavier object, it bends. This phenomena is gravitational lensing. ठीक है? Very good. So now we are moving to the standard model of the particle physics. We have the standard model of the particle physics, and the standard model, it starts from the Big Bang. Okay, जैसे ही Big Bang start हुआ, Big Bang के बाद में सारे particles, yes, Nupur? So we have the something known as the elementary particle, the smallest of the particles in the universe. Okay, and from these smallest of the particles, the big things like the planets, the stars, and the galaxies, they have formed from these tiny small fundamental particles. Okay, so standard model, it looks at the fundamental interaction. Fundamental interaction means like an electron, it interacts with a proton. So basically, how an electron is interacting with the proton. Okay, 11th 12th class में बताया गया है that an electron and a proton, they attract each other. ठीक है, and they attract each other by way of electric forces. So after some time in the 12th class, you will say that electricity and magnetism, they are the same. So basically, the scientists study the EM interaction. They call it the EM interaction. How the electron and proton, they are interacting. They are interacting through the electromagnetic interaction. बात समझ में आई? Similarly, these electron and proton, you all know that they have some mass. किसी किसी को मास भी याद होगा, प्रोटॉन का मास कितना है, इलेक्ट्रॉन का मास कितना है, and because they have mass, okay, so they will also exert gravitational force on each other. But the electromagnetic force, it is very, very larger than that gravitational force. So they are also interacting through gravity. Everyone is with me? They are also interacting through the gravity. And there is one more force, which is the strong force. Okay, and strong force, काफी छोटी रेंज में ये स्ट्रॉन्ग फोर्स ओरिजिनेट होती है जब डिस्टेंस हो जाता है 10 to the power -15 मीटर के. अगर इतनी रेंज में इलेक्ट्रॉन एंड प्रोटॉन आ गए तो ये फोर्स एक्टिव हो जाएगी. Then the force, the strong force, it will be active if you can bring an electron and a proton closer to each other. Okay, and that distance should be, they should be close enough to 10 to the power -15 मीटर. तो उस केस में इलेक्ट्रॉन एंड प्रोटॉन कंबाइन होके न्यूट्रॉन उनका बन जाएगा. Yes, people, nuclear force is strong. So Strong force is also there. Strong force is also a force of nature. And also we have one more force. Three forces we have discussed, and we have one more force. We have one more force, and that is the weak force. So the scientists, they witnessed some phenomena. They witnessed the alpha decay. Alpha particle is basically the helium nucleus. Okay, so they witnessed the alpha decay, and they also witnessed the beta decay, radioactivity, and they realized that these processes, they are governed by a third kind of interaction, and that interaction is the weak force. We cannot explain beta decay by strong force, by gravitational force, or by the electromagnetic interaction. So this is a different interaction. This is the weak force. And we have only these four forces. These are the fundamental forces that are existing in the nature. सबको समझ में आया? Okay. So the standard model of particle physics, okay, in particle physics, we are studying the interaction between these fundamental building blocks of the universe. Okay, we are studying these basic interaction between these very basic particles which have formed our complete universe. Okay, and we have a standard model of particle physics, and the standard model is based on this equation, and we will not read this equation. Okay, हमको जरूरत नहीं है, हम बस देखेंगे कि इस मॉडल से हो क्या रहा है. We are more interested in what is the implication of these beautiful mathematical theories. Okay, so this is also a very beautiful coincidence, or we can call it coincidence or anything else, that beautiful mathematical equations, they are describing the physical reality. Okay, so this is a mathematical equation, and this mathematical equation, it describes the physical reality. Likewise, you studied a very simple equation, vector equation, f equals to ma in your 11th class. Okay, that was the vector equation, and it was for the first time that you were you encountered these laws of nature, and it was a simple vector equation, and eventually the difficulty level grows, and now we have these kind of equations, these f mu nu, these are the tensors, and this is operator algebra. We do not have to go into it. So we have four fundamental forces in nature. One is the force of gravity. I have already discussed. It is the weakest of all the forces, and it has infinite range. Sun भी हमारे अर्थ को यहाँ से pull कर रहा है. Okay, so this has very large range. This has infinite range. Then we have the weak nuclear forces, and these forces, they are also short range, because ये हमको बीटा डीके में ही एनकाउंटर हुई, ओके, ये अल्फा डीके में, and so they have short range and they operate inside the nucleus, okay, at short ranges. Then we also have the electromagnetic interaction, and this is the this is a strong force, also has the infinite range. And I also discussed the force which binds the nucleus together, which can even bind an electron and proton, and even a proton and proton together. So we have the strong nuclear forces, and these are very short range forces, 10 to the power minus 15 meter. If you bring two particles in this range, they will attract, and otherwise the strong force, it falls rapidly. And a strong force is the strongest that we have encountered in nature. नेचर के अंदर ये सिर्फ चार फोर्सेस हैं और कोई फोर्स नहीं है. You are standing on the ground, that is because of the electromagnetic force of the ground. Okay, I can write on this tablet and it is appearing on your screen because there is friction between the tip of the pen and this tablet. Okay, so that is also an electromagnetic interaction. You can see me, that is also an EM interaction because light is falling on my body and it is reflecting from my body. Okay. So in the standard model, it is the branch of physics, and it explains the phenomena involving the three fundamental forces of nature. Barring gravity, okay, बस gravity को छोड़ दो, it explains all the three interactions very well. Okay, so gravitational force is outside the purview of the standard model. And scientists, for this precise reason, they are working on a new theory, which is the string theory. Because they want to develop a theory which can describe all the four forces. So they are working on a string theory, and they are working also on the grand unification theory. But that is not our domain. हमको सिर्फ इतना जानना है, be it the standard model, बात को ध्यान से सुनना, be it the standard model, be it the grand unification theory, be it the general theory of Einstein, or be it the string theory. Okay, these all are there because we want to explore our universe. We want to know about the structure of the universe. Okay, how the planets, how the human beings, how the biological molecules, how the sun and the galaxies, they are formed. Okay, so through these various theories, we are inspecting only one question. Okay, the structure of our universe. Clear सबको? ये भी मैंने बता दिया है that weak nuclear force radioactivity में involved है. Okay, beta decay, strong nuclear force. Okay, the phenomena of fusion and fusion, it can be explained only by the strong nuclear force, the stability of the nucleus. Strong nuclear force also exists, and also we have the electromagnetic force. And this force you encounter in your everyday life, and even the gravity you encounter in your everyday life. But the standard model, it explains these three interactions very well. So this particle physics is the branch of physics where we inspect the fundamental particles, okay, that have made up this whole universe. The complete universe and the matter, it is made up of these particles. Like the electron, we have the electron and we have the proton. Okay, the atoms, they are composed of these particles. So it is the branch of physics which inspect the fundamental particles. Okay, so what are these fundamental particles? Particles which cannot be broken down further, like the electrons. Okay, electrons, electron is a fundamental particle and you cannot break it down further. Okay, electron, we are not able to even determine the size of the electron, that what is the diameter of the electron. We have not measured it, and we have not witnessed anything smaller than the electron. Okay, so electron is a fundamental particle. But a proton and neutron, they are not called as fundamental particles. You all know that a neutron is formed by an electron and a proton, which are bind together in a very smaller region. Okay, and a proton is made up of something more fundamental. A proton is made up of three types of quarks. I will explain it further. What this U, basically U is, these are three quarks. A proton is made up of three quarks. Q-U-A-R-K. So the quarks, they are the fundamental particle. Electrons, they are the fundamental particle. We cannot break them down further. Okay, that is the meaning of the fundamental particle. Kritika, what is up and down? What do you want to say? Yes, up quark, down quark. Yes, Kritika, absolutely. These are the names given to these quarks. Okay. So from the standard model of the particle physics, we must have a variety of quarks, and that is why we have up quark, we have the down quark. Basically, there are 6 quarks, and I will explain it. So, from the standard model of particle physics, okay, I will come to this diagram later. See, the standard model of particle physics, it says that we have a category which is known as the elementary particles or the fundamental particles. Okay, we have elementary particles or the fundamental particles. And these particles, they cannot be broken down further. Okay, these are the basic building blocks of all the universe. This is fine. Then these elementary particles, they are divided in few categories, like we have the quarks and we have the leptons. One is quark and one is lepton. Okay. So by the prediction of this standard model, we have 6 quarks. We have the up and down. Okay, we have charm and strange, and we have top quark and we have the bottom quark. Okay, so we have 6 kinds of quarks: up, down, charm, strange, top and bottom. So these quarks, they are the elementary particles, they are fundamental particles. Meenu, you want to ask something?
So one is charged and second is?
See, the U is up quark, UP up, and D is down quark, DOWN,
Yes, sir.
and C is charm, CHARM.
Charged.
Yes. S
And
is strange, Dr. Strange,
okay.
and T is top, and B is bottom. These are the name given to these fundamental particles that are known as quarks. So Kritika, charm and strong, it is charm and strange. Okay. And we have another category which is known as the leptons. Okay, and in leptons we have electrons, we have muon, okay, and we have tau. So electron, muon and tau, these are also fundamental particles. Okay, and the protons and neutrons, the proton is made up of 3 quarks, and likewise the rest of the particles, they are made up of these quarks. Okay, these are the fundamental elementary particles. So these quarks and these leptons, you all must have heard about the spin of the electron or spin of the proton, okay, or spin of a photon. Have you heard it? Okay. Spin is basically a kind of angular momentum. This is a complex concept. Just understand it in a very simple way. Like our Earth is rotating around the sun. So because of rotation, we have some angular momentum with the Earth, and Earth is also spinning on its axis. So these are 2 motions. Okay, this is an analogy. And similarly, we have two kinds of spins, two kind of angular momentum. One, the particle is itself moving in this space. Okay, because of that motion, we have the angular momentum. And second momentum, we have the kind of spin. अभी ऐसे याद कर लो, बाकी इसके लिए फिर पूरी क्वांटम मैकेनिक्स पढ़नी पड़ जाएगी, सो उसमें इंटरेस्ट नहीं है. सो ऑल ऑफ दीज पार्टिकल्स दे हैव half spin, half integer spin. Either the spin will be half or the spin will be, okay, multiples of 1 and half. It can be 3/2, it can be 5/2. So these are the values of the spin, and when the spin is half integer, these particles are known as fermions. Okay, and similarly, when the spin is a whole number 1, 2, 3, then those particles, they are known as bosons. B-O-S-O-N-S. So have you heard about the Bose-Einstein statistics? Have you heard this name, Bose-Einstein statistics? Yes, basically that physics describes the bosons, the particles which have the integer spin 1, 2 or 3. Okay, bosons, so they are those particles which have the integer spins. Fermions have half integer spin. It will be either 1/2, 3/2 or 5/2. Okay, and in case of boson, this spin will be like 1, 2 and 3. Okay,
So all of these half 3/2 or 5/2 spins, all are known as fermions.
see, fermions are those particles which have the half integer spin. A fermion can have 3/2 spin, a fermion can have 5/2 spin. Okay, fermion can have any of these numbers.
Okay.
There is a property known as, okay, spin, and these numbers are basically assigned from the theory, and basically it means if any fermion has half integer spin, then sorry, okay, then its angular momentum will be something like 1/2 h cross. This h cross has a dimension of angular momentum. Don't go into that. Simply put, fermions are those particles which have half integer spin, and bosons are those particles which have integer spin. No, so I will talk about the bosons. Okay, I will cover it. Don't worry. So I told you that we have a up quark, a down quark, a charm quark, a strange quark, okay, a top quark and a bottom quark. Very well. Then we have fundamental particles like the electron, like muon, and like the tau, TAU, tau. Okay, and there is also one more particle. There is a neutrino associated with an electron, and we write it with the symbol. This is the symbol of neutrino, and we put a small e. Okay, in the suffix we put a small e, and that means the neutrino associated with the electron, and with this means the neutrino associated with the muon, and this means the neutrino associated with the tau. So we have three kinds of neutrinos. Okay, one is associated with electron, one is associated with muon, and one is associated with tau. So these neutrinos, they are also fundamental particles, and they are of three types. One is associated with electron, one is associated with muon, and one is associated with tau. Very well. So all of these particles, these are the elementary particles. Now let us talk about these bosons. We have some bosons. Like we have the most common boson is this photon. Okay, represented by a gamma. Symbol gamma. So this is a photon. A photon is a boson. And we all know that the photon, it does not have any mass. Okay, photon is a boson. And similarly, we have a gluon, and we have these bosons W and Z. So give me 2 more minutes. See, they say that in the electromagnetic interaction, okay, standard particle physics mein, they explain everything by a phenomenon known as exchange force. Okay, and in particle physics हम ऐसे बोलते हैं कि electromagnetic field, okay, electromagnetic field में electron and proton अगर एक दूसरे के साथ interact कर रहे हैं, then the interaction will be by something. If the electron and proton, they are interacting through electromagnetic interaction, then they are interacting by way of photon. So they will be exchanging photons with each other. ठीक है, तभी तो हम बोलेंगे कि कुछ interaction हुआ है. So in electromagnetic interaction, the exchange particle is the photon. और जब भी वो interaction होता है, we say that they are interacting electromagnetically. बात समझ में आई? इलेक्ट्रोमैग्नेटिक फोर्स से इंटरेक्शन होने का मतलब है टू एंटिटीज दे आर एक्सचेंजिंग द फोटॉन्स. हमेशा स्टैंडर्ड मॉडल ऑफ पार्टिकल फिजिक्स ने यही बताया कि दिस इज नोन एज द एक्सचेंज फोर्स बिकॉज दीज टू पार्टिकल दे आर एक्सचेंजिंग द फोटॉन्स. सो देयर इज अ फोर्स, इलेक्ट्रोमैग्नेटिक फोर्स बिटवीन देम. एंड सिमिलरली वी हैव द ग्लूऑन्स. If we have quark 1, if we have a quark and we have another quark, then because like there we have the EM field, here we will have the quark field, and they will exchange a particle which is known as gluon. Electromagnetic force के केस में जो particle exchange हो रहा था, that was the photon, and here the particle that is exchanged it is gluon, and the force is arising because of exchange of these particles. बात समझ में आई? 11th 12th में इलेक्ट्रोमैग्नेटिक फोर्स पढ़ते थे. सो स्टैंडर्ड मॉडल के अंदर दो पार्टिकल आपस में अट्रैक्ट इसलिए कर रहे हैं बिकॉज दे आर एक्सचेंजिंग फोटॉन्स विद ईच अदर. Okay, and in the weak interaction, Kritika, this is standard model of particle physics. Okay, the charge is not the photon. They are interacting by exchanging photons. Okay, and the force, the thing that we call as electromagnetic force, that is because they are exchanging the photon. A charged particle, if it is interacting with another charged particle, then it is exchanging photons. Photon is basically the mediator. Okay, interaction is happening by via photon, and as a result of this interaction they are pulling each other. Attractive force वहां से originate हुई. So charge is not photon. And in the weak force, in case of the weak force, we have the W and Z bosons. They will be exchanged. W and Z bosons will be exchanged in case of weak interaction. Is it clear? And gravity does not come under the standard model. It cannot explain it. But in case of gravity also, they expect the gravitons to exist. There should be gravitons. Okay. So under the particle physics, we have the matter particles that are known as fermions with half integer spin. We have the quarks and leptons. Leptons are of three kinds: tau, muon and electron. और इनके साथ जुड़े हुए इनके न्यूट्रिनो, tau neutrino, muon neutrino and electron neutrino. Very well. Then quarks, they combine to form the another they combine to form the particles known as hadrons. Okay, and hadrons, they collectively, okay, terminology for mesons and baryons. You do not have to remember it. Basically quarks, they will combine together and quarks will form another composite particles. Quarks आपस में combine करके proton बना देंगे, neutron बना देंगे. Okay, and all of these particles, pions, kaons, ये सब particle, पूरा universe basically, the building blocks are the quarks and leptons. Okay, and we have these bosons, and these bosons are the reason for the force between any two particle. Okay, and these bosons are responsible for those forces. Electromagnetic interaction में the photons are exchanged between two particles and they interact by the exchange of photon, and because of that exchange we have a force. Okay, and in particle physics we say that it is the exchange force. Similarly, for the weak nuclear force we have W and Z bosons, and for the strong nuclear force we have the gluons. Okay, सभी को बात समझ में आई? Photons we can encounter in our everyday life, W and Z bosons, okay, and the gluons. So large hadron collider, CERN Geneva के अंदर, in CERN Geneva, all of these bosons they have been discovered. Inside this CERN Geneva, all of these particles and even the antiparticles. Standard model कहता है that all of these particles must have their own antiparticle also. So जितने भी antiparticles हैं and जितने भी ये bosons की मैंने बात की, WZ, gluon, ये सब CERN laboratory में observe हो चुके हैं. So standard model is correct. ठीक है, CERN के अंदर क्या हो रहा है? जो basic physics describe कर रही है fundamental particles को. Okay, we are validating that physics in the laboratory in the CERN. The particle physics laboratory that we have in CERN, Geneva, at the Swiss-France border. Okay, at those laboratories we are validating the standard model of particle physics, which explains the, okay, these building blocks of the universe. So we have the leptons, electron, muon and tau, and these electrons, muons and tau, we have associated antineutrinos with them. Okay, and they are interacting by the exchange of weak bosons. Okay, and the charged particles, they are interacting by the exchange of photons. Okay, and the quarks, because they are participating in both the weak interaction and the strong interaction, so they exchange both the gluons and these weak bosons and gamma photon. तो ये diagram UPSC के लिए इतना relevant नहीं है. It just explains because the quark, they interact through all the three kinds of forces. So the quarks, they can exchange even the photon, the weak boson and the gluons. Yes, we know. So the standard model ने एक और चीज predict की थी. Standard model it predicted one thing also, that is known as the Higgs boson. And standard model says that at the time of the Big Bang, when the universe get inflated, okay, then all of the particles, they were massless. Okay, all of the particles, they were massless at the time of the Big Bang, but there was something known as the Higgs field. There was something which is known as the Higgs field, and when these material particles, they interacted with the Higgs field at the time of the Big Bang, so in that interaction, okay, in that interaction, the particles, they gain their mass. So electron is less heavier because it interacts, okay, it interacts with, at a lesser magnitude with the Higgs field, and those particles which are heavy, they interact more with the Higgs field. जो Higgs field के साथ कम interact करेगा उसका mass कम होगा, और जो Higgs field के साथ ज़्यादा interact करेगा उसका mass ज़्यादा होगा. Okay, so neutrinos का mass electrons से कम है. So क्योंकि neutrinos, they interact with the Higgs field with less strength. so they are less massless. And the photons they do not interact with the Higgs field, so the photons are massless. Why the photons are massless? Because they don't interact with the Higgs field. Okay, photons, they are antisocial, they do not mix with anyone, and so they do not have any mass. Okay, and in particle physics, if two things they are interacting, there must be a mediator. अभी मैंने बताया particle physics में, because the charged particle they are interacting through EM force, then there must be a mediator, and that mediator was the photon. ठीक है? Strong force के केस में, because the electron and proton they are attracting each other inside the nucleus, the proton and proton they are attracting each other inside the nucleus, so there must be some mediator because of which the force is arising. ठीक है, एक मीडिएटर की जरूरत है फोर्स अराइज होने के लिए. स्ट्रॉन्ग फोर्स के केस में वो ग्लूऑन है, ईएम फोर्स के केस में वो फोटोन है. ओके, एंड वीक इंटरेक्शन के केस में वो डब्ल्यू एंड जेड बोसॉन्स है. फाइन. सो इसीलिए हिग्स बोसॉन को प्रेडिक्ट कर रहा था स्टैंडर्ड मॉडल. स्टैंडर्ड मॉडल वाज प्रेडिक्टिंग द हिग्स बोसॉन. फाइन. And because this Higgs boson is the mediator in case of the interaction between any particle and the Higgs field, and because of that interaction the mass arises. Okay, so in the year 2000, and in which year it was discovered? In the year 2012. The Higgs boson was discovered in 2012. And that validated the standard model of particle physics, and that even explained how all the particles in the universe they have acquired their mass. Okay, so कुछ समझ में आया? What was this Higgs boson? The particles they were interacting with the Higgs field, and for interaction there has to be a mediator, and that mediator was the Higgs boson. और स्टैंडर्ड मॉडल की प्रेडिक्शन के अकॉर्डिंग ये एग्जिस्ट करना चाहिए था, एंड इट वाज डिस्कवर्ड इन द ईयर 2012 in this large hadron collider. Okay, please write the full form of CERN. Basically CERN, initially it was given some name in the French language, so the name goes CERN, but the full form, the English full form is European Organization for Nuclear Research. CERN is European Organization for Nuclear Research. सबने लिखा? चार्ज पार्टिकल इंटरेक्ट करेंगे फोटॉन्स के थ्रू. ठीक है, स्ट्रॉन्ग फोर्स के केस में प्रोटॉन एक दूसरे से इंटरेक्ट करेंगे थ्रू स्ट्रॉन्ग फोर्स बाय मीडिएटिंग द ग्लूऑन. और वीक इंटरेक्शन में जो एक्सचेंज होगा वो होगा वीक बोसॉन्स का, डब्ल्यू एंड जेड बोसॉन्स. एंड बिग बैंग के स्टार्टिंग में, बिकॉज ऑल द पार्टिकल्स दे इंटरेक्टेड विद द हिग्स फील्ड एंड दे गेन देयर मास. और इंटरेक्ट कैसे किया होगा? बाय थ्रू सम मीडिएटर. दैट मीडिएटर वाज द हिग्स बोसॉन. तो हिग्स बोसॉन को भी डिस्कवर होना चाहिए था. ओके, हिग्स बोसॉन इट शुड एग्जिस्ट. So they discovered inside the lab the existence of Higgs boson, and this is also known as the God particle. Now let us talk about the neutrinos. सबको समझ में आया? स्टैंडर्ड मॉडल से हम क्या करने की कोशिश कर रहे थे? We are basically inspecting the structure of the universe. Okay, to increase our understanding of the universe. This was our basic aim. सबको समझ में आया? आगे बढ़ सकता हूँ? More than sufficient है, more than sufficient. कोई भी क्वेश्चन जो भी फ्रेम होंगे, okay, they will be very easier ones. And अगर इसके बाद अब क्लास नहीं भी करोगे तो जो दिमाग में जितना भी है उससे मेरे ख्याल से सही आंसर टिक करने में कोई परेशानी नहीं होगी. But now you can also answer that why we are establishing the Indian LIGO. Why are we wasting so much of money in establishing the LIGO project? Okay, there are some 12 billions of rupees. The Indian government is giving 12 billion rupees for this project. Okay. Harsh Verma, I gave you the example, very simple example. This question was asked in the year 2018. And this question was asked because the Einstein was so much in news because of the discovery of the gravitational waves. Okay, and now that we are establishing the LIGO detectors, okay, it will remain in news. Every now and then we will encounter the gravity waves. So this question was in 2018 because that was in news. UPSC will ask only those things which remain in news frequently. And it was a simple question. Light is affected by gravity. Universe is constantly expanding. Okay, matter warps its surrounding space-time. So in the mains examination, the questions, they will be more from the topics like artificial intelligence, or from this topic they can be very generic, that what is the use of establishing the LIGO laboratory? Okay, how will it help India? So such kind of questions will be framed, and for that you must have some further points to write. But in the case of mains examination, the blockchain, the artificial intelligence, okay, the robotics, space, these are the favorite topics. And the particle physics, and for the gravity waves also, so many countries, they have collaborated with each other, and that is why even this gravitational waves and the particle physics, the experiments that are going on in CERN, because every country is spending so much in the research relating to the particle physics or relating to the telescopes and the gravitational waves, because okay, you are getting my point now. So each of the country, they are spending a lot of money in this research, so it becomes important from the UPSC perspective. Got Marlowe things that are in news, they are important. सिर्फ पॉलिटिकल न्यूज को छोड़ के कि राहुल गांधी क्या कर रहा है या बाकी पार्टीज के मेंबर क्या कर रहे हैं, मोदी जी क्या कर रहे हैं, मोदी जी तो चलो पीएम है, तो पॉलिटिकल न्यूज और क्रिमिनल न्यूज छोड़ देंगे, देन ओके एवरीथिंग दैट रिमेन्स इन न्यूज, इट इज इंपॉर्टेंट फ्रॉम योर एग्जाम्स पर्सपेक्टिव. और इसीलिए सिलेबस याद होना बहुत जरूरी है. सिलेबस सबकी दीवारों पे चिपकाया था ना. So let us talk about these neutrinos, and we are talking about neutrinos because India has established, India is establishing an observatory that is known as the INO, Indian Neutrino Observatory. Okay, and in this laboratory is coming up in Tamil Nadu. This laboratory is coming up in Tamil Nadu, and we will study neutrinos there. And neutrinos, they will help us in understanding again the structure of the universe. Okay, and we can answer some of the questions. We are discovering the answer to the questions that we do not know, and there are so many questions that we do not know, like what is the dark matter, okay, how the dark energy is expanding the universe. So these all are the unanswered questions. Okay, so and these neutrinos, they are the second most abundant particle in the universe, और सबसे ज़्यादा abundant जो हैं, are the photons. So photons are the most abundant particle, and neutrinos, they are the second most abundant particles. And these neutrinos, they are produced in weak interaction. अब सबको पता है what is this weak interaction? So neutrinos, they are produced in the weak interaction. For example, in the radioactive decays, in alpha, beta, and in alpha beta decay, the neutrinos are produced. Neutrinos, they are associated with weak interaction, and they are produced in the radioactive decays also. And these are elusive subatomic particles. These are also fundamental particles. They are elusive. Elusive meaning इनको डिटेक्ट करना बिल्कुल भी इजी नहीं है. For this reason they are elusive. Okay, इतना ही बहुत है न्यूट्रिनोज के लिए. And neutrinos, they are almost massless. They have some mass, लेकिन उसको अभी तक मेजर नहीं किया गया है. Mass, their mass is non-zero. They are almost massless. Okay, but अभी तक डिस्कवर नहीं किया गया है कि what is the mass of the neutrino. And they interact only through gravitational and weak interaction. Neutrinos electromagnetic interaction में, okay, if an electron is attracting a proton, then that is an electromagnetic interaction, and in that interaction the neutrinos, they cannot be produced because they interact only through the gravitational wave and the weak interaction. Very well, we have the four forces and they interact only by two of the forces, weak interaction and the gravitational. And it is for this reason, it is very difficult to detect them. We cannot detect them by the use of, okay, the gravitational force, because they are almost massless. They are almost massless and they participate only in the weak interaction. So most of the neutrinos, they pass through the matter without interacting with the matter. Okay, every second, here we have some fact, every second there are 3 million billion neutrinos. That means 3 into million is 10 to the power 6 and billion is 10 to the power 9. So it becomes 10 to the power 15. So every second 10 to the power 15 neutrinos, they pass through each square centimeter of the earth surface. Okay, इस टाइम पे सब आप लोग पढ़ाई कर रहे हो, then neutrinos, they are passing through your body. Okay, billions of neutrinos, they are passing through your body each second. Okay, and all of you are certain that the neutrinos, they are not harming you. Okay, because the neutrinos, they are not interacting with the electrons, protons and molecules inside your body. सब इस बात से एग्री करेंगे, the neutrinos, they are not interacting with anything that your body is made up of. So it is very difficult to detect them. And in order to understand the structure of the universe, the scientists, they want to study them. And for this reason, okay, an India-based neutrino observatory for the study of elusive neutrinos, this laboratory will be established in India. And their primary task will be to determine the mass of the neutrino, okay, which is almost massless, but we want to determine if it is having very small mass, what is that number, because the mass of the neutrino is still undetermined. And there is one more thing, property of neutrino, neutrino oscillates. And that means that I told you earlier that there are 3 types of neutrinos: electron neutrino, muon neutrino and tau neutrino. And as the neutrino passes through the space, okay, as the neutrinos, they move through the space with the speed of the light, okay, they change their flavor. That means they change their form. They change from one type to the another. Okay, an electron neutrino, it will convert to muon neutrino, and a muon neutrino, it will convert to tau neutrino, and it is both ways. So this phenomena is known as the neutrino oscillation. Okay, so neutrinos, they oscillate between different flavors, means different types of neutrinos. The neutrinos changes between the different type of neutrinos, they change their form when they travel through the cosmos. So जैसे कोई भी neutrino space से travel कर रहा है, and electron neutrino, it gets converted into the muon neutrino. Okay, oscillate करता रहता है between the two forms. So we will try to get answers to all these questions, that why this is happening, and hopefully by getting answers to these questions we can unravel the mysteries of the universe. ठीक है, सबको बात समझ में आई? Very good. So INO will be a world-class underground laboratory, and it will be beneath a rock cover of approximately 1200 meters. Okay, ऊपर एक rock का structure है, and below that we have this neutrino laboratory. Okay, so it is the non-accelerator based high energy nuclear physics. Non-accelerator based means actually in the CERN in Geneva, what we are doing is, in CERN Geneva we have, okay, circular tracks of many kilometers, 20, 30 kilometers, and in these tracks they accelerate the particles like electrons and protons, and these particles, okay, they collide at some point, and in those collisions, because these particles are accelerated at very high speed comparable to the speed of light, and in those collisions particles like Higgs bosons are produced. So that is why that is known as high energy physics. यहाँ पे न्यूट्रिनो लेबोरेटरी के अंदर हम पार्टिकल्स को एक्सीलरेट नहीं कर रहे हैं, ओके, सीधे न्यूट्रिनोस अर्थ से हर घंटे हर सेकंड इतने सारे न्यूट्रिनोस पास हो रहे हैं. सो वी विल ट्राई टू study them and we will try to derive the answer to some of the questions. Okay, and this project is funded by Department of Atomic Energy and Department of Science and Technology. Department of Atomic Energy, it is under the PMO, and Department of Science and Technology, it is under the Ministry of Science. Okay, and this laboratory is coming up in the Body Hills in the Theni district of Tamil Nadu. We have this Body West Hills complex in the Theni district of Tamil Nadu, और वहां पे गांव है पोटीपुरम, where this Indian Neutrino Observatory will come up. Okay, fine. Department of Science and Technology comes under the Ministry of Science. Okay. Now there is one more thing, optical fibers. We are using optical fibers, okay, everywhere for the communication purposes, and these optical fibers, they are based on one phenomena, one principle, which is known as the TIR. Okay, I will explain you what is this TIR. Suppose you have a rarer medium, okay, and here we have a denser medium. Now if a ray of light, for example, let us take this is, we have water and the above surface, this is air. We have the water to air interface. This is the interface between water and air. And suppose a ray of light is moving from the denser medium to the rarer medium. What will happen to the ray of light? What will happen to the ray of light? It will reflect, it will refract. Okay, refraction will take place, and the light will move towards the normal or away from the normal. Very good, it will move away from the normal. Okay, if you keep increasing the angle of incidence, if you will increase the angle of incidence, okay, so the light, it will bend further. then there exists one angle. There will be one angle for which the angle of refraction, it will be 90 degree. The light will be refracted along the interface. Okay, the light यहाँ से जैसे ही incidence angle बढ़ेगा, then light will be, it will pass more closer to the surface. Critical angle. Yes, Aditi, it is critical angle. And if the angle is more than this critical angle, the light, it will reflect. Instead of refraction, reflection हो जाएगा. ठीक है. लाइट जब भी रेयरर मीडियम में जाएगी तो अवे फ्रॉम द नॉर्मल बैंड होगी. ओके, एंड जैसे जैसे हम इंसिडेंस के एंगल को इंक्रीज करेंगे, देन एंगल ऑफ रिफ्रैक्शन भी इंक्रीज होता रहेगा. एंड देयर विल कम अ पॉइंट फॉर द इंसिडेंस एंगल IC, the angle of refraction will be 90 degree. Angle of refraction IR, it will be 90 degree for some critical angle. और उससे ज्यादा एंगल बढ़ा देंगे, then there will be reflection. लाइट अंदर ही रिफ्लेक्ट हो जाएगी, दूसरे मीडियम में नहीं जाएगी. Fine. Now there is one angle. Suppose this is the critical angle IC. And if you are sending a ray, okay, at an angle more than IC, then the ray will reflect inside the medium. The condition is only that the angle of incidence I, it should be greater than IC. Very well. यही total internal reflection है. Okay, ना इससे कुछ ज्यादा ना इससे कुछ कम. And the optical fibers, they are the direct application of total internal reflection. यहाँ पे ray of light, अंदर एक core fiber है, and this core fiber की जो refractive index n है, the refractive index of this core fiber, it will be less than the outer layer. It will be less than the refractive index of the cladding. Cladding means एक कांच का फाइबर ले लिया और उसको एक लेयर से कवर कर दिया जिसकी रिफ्रैक्टिव इंडेक्स कांच से कम है. ओके, तो और TIR की कंडीशन ही यही है कि दैट लाइट शुड मूव फ्रॉम डेंसर टू रेयरर. TIR के लिए डेंसर मीडियम से रेयरर मीडियम की तरफ लाइट को जाना चाहिए. सो हम लाइट को इंजेक्ट कर रहे हैं अंदर वाली कोर के अंदर, और जब वहां से लाइट मूव करती है, देन इट मूव्स टुवर्ड्स द रेयरर मीडियम, एंड दिस TIR फिनोमेना हैपेंस. ओके, लाइट अंदर ही अंदर रिफ्लेक्ट होती रहेगी, एंड इट विल मूव अनहिंडर्ड इन दिस मैनर. So by the use of optical fibers, these signals, they will remain unaffected by the electromagnetic interference. Okay, and it also consumes low power. And these fibers, they are very thin. Okay, they are economical and they do not catch fire. This is all about optical fiber. They uses one phenomena of physics which is known as the total internal reflection. Okay, and we use optical fibers because they are free from the electromagnetic interference and they consume less power. Okay, they are economical and they do not catch fire. Yes, Kritika, even they are durable. So I have completed the gravitational waves, the black holes, okay, and the particle physics, standard model, and the Higgs boson. And also this optical fiber. Okay, and I told you about the the laboratory sun that was involved in the discovery of Higgs boson, and in the gravitational waves, the LIGO observatory was involved. They are inspecting the larger cosmos, the larger universe, and in the particle physics, we inspect at the very fundamental level, at the level of the electrons and even beyond that. Okay. So we have completed all these topics, and now we will move to the biotechnology. Now we will move on to biotechnology. Now, do you want to ask any question related to the topic gravitational wave, black holes, neutron stars? Disha, you will revise the syllabus, okay? I will give you a brief summary. See, the gravitational waves, Einstein said that the gravity is not a force, and gravity is related to the geometry of the space. Okay. And because of the geometry of the space, the light rays, they bend near the heavier bodies. Okay. And because of the mass, the space-time, it gets warped. The space and time gets distorted due to mass and energy. It gets distorted, or it gets warped because of mass and because of energy. Okay. And near the very massive objects, if the objects, they get too heavy and they get too dense, then the space, it can warp infinitely. The space, it can get curved infinitely, or in other words, we can say that the gravity is infinite. Okay. If too much amount of mass is packed in too less volume, okay, density will be very high. In that case, the space will be infinitely curved. Or we can say that the gravity is very, very strong, and in such case, the black holes are formed. Okay, and at the center of the black hole, the space is infinitely curved. That means the laws of physics, they do not apply at the center of the black hole. Okay. And also, when the very massive objects, they very rapidly move through the space. Okay, the heavier objects like the neutron stars, when they collide, when the black holes collide, then they will jerk the fabric of the space. So in that scenario, the gravity waves will be produced. There will be a kind of ripple effect in the fabric of the space and time, and because of that effect, the gravitational waves are formed. And those gravitational waves, they were detected by the LIGO detectors. LIGO detectors in Hanford, Washington, and in Livingston, Louisiana, in the USA. So in 2015, we discovered the gravitational waves, and the general theory of relativity of Einstein, it was validated. Okay. And जो less massive stars हैं, जो few times the solar masses, they will get converted to the white dwarf. And Chandrasekhar limit says that which are less massive than the 1.44 times the solar mass, they will get converted to the white dwarf. The others, they can become the neutron star or the black holes. ओके, हैवियर जो स्टार्स होंगे, उनकी कोर के अंदर जब फ्यूजन रिएक्शन खत्म हो जाएगी, देन आफ्टर द फ्यूजन रिएक्शन हैज स्टॉप्ड, ओके, देन देयर इज नथिंग टू स्टॉप द ग्रेविटी. द ग्रेविटी इज सो स्ट्रॉन्ग दैट द स्टार कोलैप्सेस अंडर इट्स ओन वेट. ओके, Otherwise, the fusion was balancing the gravity, but when the fusion is not there, the star, it collapses under its own gravity. And if the mass of the core of the star is 1 to 3 times the mass of the sun, then the collapse will stop. Okay, and that core will be composed of neutrons, and neutrons are dense enough to counter the gravity. Okay, the collapse will stop. But if the mass is more than 1 to 3 times the mass of the sun, then in that case, the black holes will be formed. The collapse will be indefinite. The system will collapse so badly that even the concept of space-time, it does not exist at the center of the black hole. Okay, the collapse is so bad that even the general theory of relativity and the laws of physics, they do not apply to such centers. And these centers, these regions of space-time, they are precisely the black holes. Very well. And then I talked about the particle physics. In particle physics, we are dealing with the fundamental particles through which all of these universe is composed. And we were inspecting the elementary particles like the electrons, जिनको further we cannot break down. Okay, electrons को उनका further division हम नहीं कर सकते हैं. And there are many other fundamental particles like we have the muons and we have the tau and we have the quarks. इनका further division नहीं हो सकता है. ये असली में these are the fundamental particles, not the atom, not the protons, not the neutrons. Even the protons, they are composite particles. Even the neutrons, they are composite particles. So particle physics basically, it describes the interaction between these elementary particles, between the charge, between the subatomic particles. The interaction between a proton and a neutron, it will be described by the particle physics. Okay, between the neutrinos and the matter. So particle physics explains all this, and particle physics predicted the existence of Higgs boson. Because particle physics said we have a field, Higgs field, which granted mass to all of the particles, okay, that originated after the Big Bang. After the birth of the universe, all of the material particles that were formed, they were given mass by the interaction with the Higgs field. Now, particle physics says if the particles, they are interacting with anything, then they must be interacting through some medium, okay, via some mediator. So because Higgs field is giving mass to the particles, it must be interacting with the particles through some mediator, and that mediator was proposed as Higgs boson. And this Higgs boson, it was discovered in the CERN. Also, the experiments, they have validated the standard model of particle physics. Okay. अब आप लोग डिस्कस करो, आप लोगों को क्या समझ में आया. जो भी समझ में आया कोई बताना चाहेगा. ये सब ऊपर से चला गया.
Sir, general theory, elementary particles and fundamental particles are subdivided into the quarks and the leptons. Quarks typically characterized by third up-down quark, charm or strange quark, top and down quark. क्वार्क प्लस लेप्टोन जो होते हैं सर वो फैमियंस होते हैं, और वो फैमियंस जो है हाफ में शो करते हैं, जैसे 1/2 3/2 स्पिन. और जो बोसोन्स होते हैं सर वो इंटीजर्स में इंडिकेट करते हैं 1 2 3.
And the standard model, it describes which forces, which kind of interactions.
Standard model, sir, electromagnetic.
And the other? It explains, barring gravity, all the rest of the forces. It does not explain the gravity. It explains rest of the forces.
Like electrons is interacting with
Like an electron is interacting with the proton, okay,
जी.
through electromagnetic interaction. And also the electron can interact with proton through gravity. Yes, the standard model explains all the forces except the gravity. Okay. Equation, they will be easier in nature. Okay. और आगे अगर कोई भी ऐसी लैब एस्टेब्लिश होती है तो वहां से at least we can have an idea that why we are okay wasting so much of money on these laboratories.
Sir,
Yes, Deep.
sir, can you tell something about Bose-Einstein condensate?
Bose-Einstein condensate. See, for that, to describe the bosons, okay, the Bose and Einstein, they discovered the Bose-Einstein statistics. That is basically a new physics to describe the bosons. Okay, and Bose-Einstein condensate is a situation when in the ground state, we populate the ground state with the bosons. So such kind of matter has very different kind of properties. So when this kind of condensation happens, when all the bosons, they occupy the ground level, that's then we say that Bose-Einstein condensation is happening. Otherwise, take example of the atoms. Suppose we have any atom, like we have hydrogen atom, then we have several orbits are around the hydrogen atom. Okay, the electron, it can be in any of the orbit, and when the electron is in the lowest orbit, we say electron is in the ground state. Okay, similar is the case in the Bose-Einstein condensation. All of the bosons, they occupy a ground state, the lowest energy state. So when this kind of situation happens, we say that Bose-Einstein condensation is happening. But there is different thing with fermions. In case of fermions, they cannot occupy the same energy state. No two fermion can occupy the same energy state. Okay, so एक fermion से ज़्यादा एक state में नहीं हो सकता है. But in case of bosons, there is no one stopping bosons to occupy the same energy state. ठीक है? This is higher physics. Okay.
And sir, I read it is the fourth state of matter. Is it true like that?
Yes, because we do not observe these properties, okay, generally. So we have given a name, the fourth state of matter.
Okay, thank you, sir.
Okay. Basically, these are the sophisticated theories. Okay, so in the general terms, we cannot answer them. We cannot answer them in the very general terms. Okay, physics can be studied in simpler terms, but it cannot be made simpler. We have to study in its entirety. Okay, किसी चीज को सिंपल बनाने के लिए हम उसके लिम्स नहीं काटते हैं. Okay, we will try to understand it in the simple ways, but we do not. Okay, we will not try to make it simple by chopping its limbs. Otherwise, the physics is difficult, but it can be understood in a systematic way. For your question? Okay, so tomorrow I will continue with the biotechnology. I will start the biotechnology, and tomorrow we are having a 2-hour session, and we will try to cover the biotechnology, okay, in a systematic way. So this is all from my side. Take care, and we'll meet tomorrow.